Welcome to helpyourmath.com. In today's video we'll be talking about long division. On the board here I have three problems that are going to be followed by two different problems. But here we can notice we have x minus 1 divided by x plus 1, 2x plus 3 divided by x plus 1, and then x squared minus 1 divided by x plus 1. Now the method for long division is a little bit draining, but you have to keep in mind this works exactly as regular division does. And as a reminder, I'm going to put up a little bit of regular division as I'm doing the first division here now. Now in every long division problem we know it's the numerator divided by the denominator, right? So here we're going to have x plus 1 divided by x minus 1. Now collateral to this, I'm going to just put a regular two-digit number divided by a two-digit number. The reason why I'm doing this is to keep in mind that algebra and arithmetic are not far apart, and you want to keep that in mind throughout everything you're doing algebraically. It's only going to make your life easier. So here let's pick a number to divide with. I'll pick the number to be 55, and we're going to use 23 to divide it, all right? Now we're going to start with this before I get to this, because this is a binomial, this is a binomial. In other words, it works exactly like two number terms do. So here we're looking at 55 and wondering if it's divisible by 23. So first we're looking at the 23 and wondering how many 23s are in 55. So technically we're looking at the 5, we're looking at the 2. We're saying how many times does the 2 go into the 5, right? And that's 2 times, right? That's going to make 46. If we go 3 times, it'll be 60. So in this case, 23 goes into 55 twice, which makes 46. We take the difference now. The moment we take the product of 2 and 23, we get 46, and we're going to make 46 negative. The product of 2 and 23 is actually positive, though. But we're making it negative because we're dividing, right? So let's take a look at this. The same way we look at the 5 and the 2 and we say how many times does 2 go into 5, we're looking at the x and the x and saying how many times does x go into x? That's 1 time, right? So we put the 1 over the 1 the same way we put the 2 over the second 5 because it's a two-digit number. This is a binomial. We're dividing with a binomial, so the number goes over the second term. Now we take the 1 times the x plus 1. 1 times x plus 1 is just x plus 1. And then we're subtracting because of division. You see here the negative 46? I'm subtracting the 46, but it's a positive product. We have to keep that in mind when we're doing this, all right? Because now this becomes negative x and also a negative 1, all right? Because the negative distributes to each term. Now x minus x is 0, x's, and negative 1, take away another 1, becomes negative 2. Because what's actually happening here is we're multiplying the 1 times x plus 1. That gives us x plus 1, but then we're making everything negative. So if we put a negative in front of the first term, this becomes negative x minus 1. Now this also will change to negative x minus 1 because we're subtracting the result of the product. Now here we get a negative 2, and this is our remainder. Here we also get a 9, right? And this is our remainder. So what we do with the remainder here is we put it over the divisor. All right, so the result of this would be 2 remainder, 9 over 23, right? Which is the same thing as having a remainder. Now here what we do with the remainder of negative 2 is put it over the divisor of x plus 1. So our first division here in long division form gives us 1 minus 2 over x minus 1. X plus 1, sorry, not minus 1. So this is the result of the first long division problem we have, which works very much like dividing two numbers here. And the only reason why I did that again was to give you guys a good brush up on how numbers work exactly the same as algebra does. Let's work on the second one here now. We have x plus 1, and we're dividing 2x plus 3. So we're looking at the 2x's, we're looking at the x, we're dividing 2x by x, and we say how many times does x go into 2x's? 2 times. So that's going to multiply again. We get 2x's on the multiplication. Here 2 and 1 make 2. And again, we're going to make them the opposite of the product, right? So we're going to put the negative outside, and that's going to change the signs inside. So this becomes negative, this becomes negative. And now this and this add up to 0 x's. 3 take away 2 is just 1. 1 is the remainder and it's positive. So we have positive 1 over x plus 1. The quotient here will become 2 plus 1 over x plus 1 in long division form. All right. Now let's work on the last one here. This time we have a missing term, right? And every time we have a missing term, we have to fill in the gaps. It's as if somebody tells you 1,000. Well, the number 1,000 has 3 zeros. We have to account for these zeros, right? Because they're called placeholders. If we say x squared, take away 1, there's a missing term. The 0 x's, right? Because the term goes in descending order from the highest power of x's all the way to the constant. So here we have x squared plus 0 x's. Take away 1 over x plus 1. And now this is ready for long division. Without taking this step, there's no way that we could have long division, all right? So the first step we're going to do here, we're going to put the x plus 1, and we're going to divide x squared plus 0 x's minus 1. And again, we're going to follow the same format as we have with the previous two problems, and we're going to divide the x squared with the x term. How many times does x squared get divided by x? Just x amount of times. X times x is x squared. Then we have x times 1 is positive 1x's. We're going to subtract this, and the signs changed, negative, negative. Then we add them up. So here we have x squared take away x squared. That becomes 0x squared. 0x's minus x becomes minus x. We bring down the next term, negative 1. Now it's working more like division of 3 numbers, right? Everything stays pretty much the same as what you're doing when you're dividing with numbers, right? Now we're looking at negative x divided by x. That's going to be negative 1. And once we have this, we're going to multiply. The negative 1 times x is negative x's. Negative 1 times positive 1 is negative 1. Now we're going to subtract this from what we have up here. So the negative makes everything change in here. So all of these become pluses when we distribute the negative sign. So now we have negative x plus x. That's 0 x's. Negative 1 plus 1 is 0. So there's no remainder in this case. So the result of this quotient, which is x squared minus 1 over x plus 1, is just equal to x minus 1. Now most of you might have looked at this problem and said, I didn't have to do long division to do this. This is easy. I just factor the numerator, right? I have x minus 1, x plus 1. Then I'm dividing by x plus 1. This is obviously an easy problem. I don't need to use long division to do. Well, my rule for you is this. If you know what the factors are of a problem and you're using long division to do it, then you should use that problem to do long division because you already know what the result is that you're going to get, right? And this way you'll be able to help yourself advance with the mathematics you're doing, right? But now that we did these three, let's move on to something a little bit more complicated, right? I'm thinking maybe a trinomial divided by a binomial with numbers, maybe like 2x cubed. Well, let's not go so high yet, right? 2x squared plus 3x's plus 5 divided by 2x minus 3. That should be interesting. We should get some remainders there. And maybe we can do a different problem. Let's make one with placeholders that need to be added. Let's say negative 4x cubed plus 2x squared, take away 6, or let's make it plus 6, right? Over, what's a good divisor for this? Let's use 3x plus 5. Alright, those two look like good problems to do. Let's move this over a little bit so we can have space to do both. Alright, so for this one, again, we're going to just set it up. If we look, the numbers are in descending order. There's no missing gaps in these. There are no placeholders that are necessary. All we need to do with this is just divide. So let's get to work with it. And this time we don't just have an ordinary x, so this should be interesting for what we have to do for the work of it. Alright. Now as I do this problem, I'm going to put little footnotes on the left side so that it makes what I'm doing a little bit more transparent for everybody who's watching at home, right? So what we're looking at now is 2x squared plus 3x plus 5 divided by 2x minus 3. For the first term, we're looking for the leading term and the leading term of the divisor. And we're dividing it to realize what the multiplier is going to be for the quotient. So we have 2x squared divided by 2x. This, when we divide it, we get a result of x. Now that we have the product of x, the result that we're going to subtract under here to make this a lot easier for you guys, what I'm going to do is I'm going to take x and I'm going to multiply it by the 2x minus 3. And not only am I going to take regular x, I'm going to take and make that a negative x because I'm subtracting when I do the division, right? By doing this step, you have exactly what you're going to put under the 2x squared plus 3x's. This way you can just add it in a quicker fashion. Negative x by 2x's is negative 2x squared. Negative x by negative 3 is positive 3x's. So this is the first result. When I put my x up here, I'm going to have negative 2x plus 3x right under this. Now I just combine these two terms. The first two cancel, the second two add up and give me positive 6x's. I bring down the 5, I get plus 5, and I run this routine all over again. I take the 6x's, I'm dividing by 2x's, I get my quotient is 3, it's positive 3 goes up here. I take that positive 3, I make it negative, and I multiply it by my divisor, 2x minus 3. This gives me negative 6x's plus 9. I place that directly under this and I just add them up. These cancel. This gives me 14. The result is positive, so my remainder is positive 14. I put that over the divisor, which is 2x plus 3, 2x minus 3. And now I write my quotient up here. So I get the division of these two will give me x plus 3 plus 14 over 2x minus 3. It's a piece of cake once you run this fashion, all right? This makes the work a lot easier because once you figure out what the subtracting term is by making the multiplier negative, you don't have to worry about signs changing in your division, all right? The sign changing could be the most complicated part about this. I suggest for most people, if you want to do this and have a nice time, work out the change of sign before you plug it in.